Airbus confirmed in early September 2007 the adoption of composite fuselage frames for the aircraft structure. 36, 37. The composite frames would feature aluminium strips to ensure the electrical continuity of the fuselage for dissipating lightning strikes. 38. Airbus used a full mock-up fuselage to develop the wiring, a different approach from the A380, on which the wiring was all done on computers. 39. In 2006, Airbus confirmed development of a full bleed air system on the A350, as opposed to the 787's bleedless configuration. 40, 41, 42. Rolls-Royce agreed with Airbus to supply a new variant of the Trent turbofan engine for the A350 XWB, named Trent XWB. In 2010, after low-speed wind tunnel tests, Airbus finalized the static thrust at sea level for all three proposed variants to the 74,000, 94,000 lbf, 300 and 420 kN range. 43. GE stated it would not offer the GP7000 engine on the aircraft, and that previous contracts for the GEnx on the original A350 did not apply to the XWB. 44. Engine alliance partner Pratt & Whitney seemed to be unaligned with GE on this, having publicly stated that it was looking at an advanced derivative of the GP7000. 45. In April 2007, former Airbus CEO Louis Gallois held direct talks with GE management over developing a GEnx variant for the A350 XWB. 46, 47. In June 2007, John Lee indicated that the A350 XWB would not feature the GEnx engine, saying that Airbus wanted GE to offer a more efficient version for the airliner. 48. Since then, the largest GE engines operators, which include Emirates, US Airways, Hawaiian Airlines and ILFC, have selected the Trent XWB for their A350 orders. In May 2009, GE said that if it were to reach a deal with Airbus to offer the current 787 optimized GEnx for the A350, it would only power the -800 and -900 variants. GE believed it could offer a product that outperforms the Trent 1000 and Trent XWB, but was reluctant to support an aircraft competing directly with its GE90-115B powered 777 variants. 49. In January 2008, French-based Thales Group won a $2.9 billion, €2 billion, 20-year contract to supply avionics and navigation equipment for the A350 XWB, beating Honeywell and Rockwell Collins. 50. US-based Rockwell Collins and Moog Incorporated were chosen to supply the horizontal stabilizer actuator and primary flight control actuation, respectively. The flight management system incorporated several new safety features. 51. Regarding cabin ergonomics and entertainment, in 2006 Airbus signed a firm contract with BMW for development of an interior concept for the original A350. 52. On the 4th of February 2010, Airbus signed a contract with Panasonic Avionics Corporation to deliver in-flight entertainment and communication (IFEC) systems for the Airbus A350 XWB. 53. Production. In 2008, Airbus planned to start cabin furnishing early in parallel with final assembly to cut production time in half. 54. The A350 XWB production program sees extensive international collaboration and investments in new facilities. Airbus constructed 10 new factories in Western Europe and the US, with extensions carried out on 3 further sites. 55. A partially complete A350-900 XWB, destined for Finnair, on the Toulouse assembly line. December 2014. Among the new buildings was a £570 million, US dollar $760 million or 745 million euros, composite facility in Broughton, Wales, which would be responsible for the wings. 56. In June 2009, the National Assembly for Wales announced provision of a £28 million grant to provide a training centre, production jobs and money toward the new production centre. 57. Airbus manufactured the first structural component in December 2009. 58. Production of the first fuselage barrel began in late 2010 at its production plant in Illescas, Spain. 59. Construction of the first A350-900 center wing box was set to start in August 2010. 60. The new composite rudder plant in China opened in early 2011. 61. The forward fuselage of the first A350 was delivered to the final assembly plant in Toulouse on the 29th of December 2011. 62. Final assembly of the first A350 static test model was started on the 5th of April 2012. 63. Final assembly of the first prototype A350 was completed in December 2012. 64. In 2018, the unit cost of the A350-900 was US $317.4 million and the A350-1000 was US $366.5 million. 65. The production rate was expected to rise from 3 aircraft per month in early 2015 to 5 at the end of 2015, and will ramp to 10 aircraft per month by 2018. 66. In 2015, 17 planes would be delivered and the initial dispatch reliability was 98%. 67. Airbus announced plans to increase its production rate from 10 monthly in 2018 to 13 monthly from 2019, and 6 A330 are produced monthly. 68. Around 90 deliveries were expected for 2018, with 15% or almost equal to 14 units being A350-1000 variants. 69. That year, 93 aircraft were delivered, 3 more than expected. 70. In 2019, Airbus delivered 112 A350s, 87 A350-900s and 25 A350-1000s, at a rate of 10 per month, and were going to keep the rate around 9 to 10 per month, to reflect softer demand for wide-bodies, as the backlog reached 579 or 5.2 years of production at a constant rate. 71. The coronavirus crisis caused the decrease of A350 production from 9.5 per month to 6 per month, since April 2020. 72. After the crisis, a ramp-up is planned, aiming to reach a rate of 9 per month by the end of 2025. 73. Testing and certification. A prototype Airbus A350-900XWB, registered as FWXWB. During its first flight, the first Trent engine test was made on the 14th of June 2010. 74. The Trent XWB's flight test program began use on the A380 development aircraft in early 2011, ahead of engine certification in late 2011. On the 2nd of June 2013, the Trent XWB engines were powered up on the A350 for the first time. Airbus confirmed that the flight test program would last 12 months and use 5 test aircraft. 75. The A350's maiden flight took place on the 14th of June 2013 from the Toulouse-Blagnac Airport. 1. Airbus's chief test pilot said it just seemed really happy in the air. All the things we were testing had no major issues at all. 76. It flew for 4 hours, reaching Mach 0.8 at 25,000 feet after retracting the landing gear and starting a 2,500 flight test campaign. 77. Costs for developing the aircraft were estimated at 11 billion euros, $15 billion or 9.5 billion pounds, in June 2013. 78. A350 XWB-MSN 2 underwent 2.5 weeks of climatic tests in the unique McKinley Climatic Laboratory at Eglin Air Force Base, Florida, in May 2014, and was subjected to multiple climatic and humidity settings from a high of 45 degrees C, 113 degrees Fahrenheit, to as low as 40 degrees C, 40 degree F. 79. The A350 received type certification from the European Aviation Safety Agency, EASA, on the 30th of September 2014. 80. On the 15th of October 2014, EASA approved the A350-900 for ETOPS 370, allowing it to fly more than 6 hours on one engine and making it the first airliner to be approved for ETOPS beyond 180 minutes before entry into service. 81. Later that month, Airbus received regulatory approval for a common type rating for pilot training between the A350 XWB and A330. 82. On the 12th of November 2014, the A350 received certification from the FAA. 83. On the 1st of August 2017, the EASA issued an airworthiness directive mandating operators to power cycle reset earlier 350-900s before 149 hours of continuous power on time, reissued in July 2019. 84. Entry into service. Qatar Airways first A350-900 XWB, registration, A7ALA, after the first commercial flight to Frankfurt Airport in June 2011. The A350-900 was scheduled to enter service in the first half of 2014, with the -800 to enter service in mid-2016, and the -1000 in 2017. 85. In July 2012, Airbus delayed the -900's introduction by 3 months to the second half of 2014. 86. The delivery to launch customer Qatar Airways took place on the 22nd of December 2014. 87. The first commercial flight was made on the 15th of January 2015 between Doha and Frankfurt. 2. The first A350-1000 was assembled in 2016 and had its first flight on the 24th of November 2016. 88. The aircraft was then delivered on the 20th of February 2018 to Qatar Airways, which had also been the launch operator of the -900. 89. And entered commercial service with a flight from Doha to London on the 24th of February 2018. 90. Shorter A350-800. The 60.45 m, 198.3 feet, long A350-800 was designed to seat 276 passengers in a typical 3-class configuration with a range of 8,245 mi, 15,270 km, 9,488 mi, with an tow of 259 t, 571,000 pound. 91. In January 2010, Airbus opted to develop the -800 as a shrink of the baseline -900 to simplify development and increase its payload by 3 t, 6,600 pound, or its range of 215 mi, 460 kilometers, 290 mi. But this led to a fuel burn penalty of a couple of %, according to John Lee. 92. The previously Planned optimization of structure and landing gear was not beneficial enough against better commonality, and maximum takeoff weight increased by 11 t from 248 t.93. The 800's fuselage is 10 frames shorter, 6 forward and 4 aft of wing, than the 900 aircraft. 94. It was designed to supplement the Airbus A350-200 long-range twin. 95. Airbus planned to decrease structural weight in the -800 as development continued, which should have been around airframe 20. 96. While its backlog reached 182 in mid-2008, it diminished since 2010 as customers switched to the larger -900. 97. After launching the Airbus A330neo at the 2014 Farnborough Airshow, Airbus dropped the A350-800, with its CEO Fabrice Brigia saying, "I believe all of our customers will either convert to the A350-900 or the A330neo." 98. He later confirmed at a September 2014 press conference that development of the A350-800 had been cancelled. 99. There were 16 orders left for the -800 since Yamaniya switched to the -900 and Hawaiian Airlines moved to the A330neo in December 2014. 8 for Aeroflot and 8 for Asian Airlines, both also having orders for the -900.100. In January 2017, Aeroflot and Airbus announced the cancellation of its -800 order, leaving Asian Airlines as the only customer for the variant. 101. After the negotiation between Airbus and Asian Airlines, 102. Asiana converted orders of 8 A350-800s and an A350-1000 to 9 A350-900s. 103. Longer A350-1000. In 2011, Airbus redesigned the A350-1000 with higher weights and a more powerful engine variant to provide more range for trans-Pacific operations. This boosted its appeal to Cathay Pacific and Singapore Airlines, who were committed to purchase 20 Boeing 777-9s, and to United Airlines, which was considering Boeing 777-300s to replace its 747-400s. 104. Emirates was disappointed with the changes and cancelled its order for 50 A350-900s and 20 A350-1000s instead of changing the whole order to the larger variant. 104. Assembly of the first fuselage major components started in September 2015. 105. In February 2016, final assembly started at the A350 final assembly line in Toulouse. 3 flight test aircraft were planned, with entry into service scheduled for mid-2017. 106. The first aircraft completed its body join on 15 April 2016. 107. Its maiden flight took place on the 24th of November 2016. 88. The A350-1000 flight test program planned for 1,600 flight hours, 600 hours on the first aircraft, MSN 59, for the flight envelope, systems and power plant checks, 500 hours on MSN 71 for cold and warm campaigns, landing gear checks and high-altitude tests, and 500 hours on MSN 65 for route proving and ETOPS assessment, with an interior layout for cabin development and certification. 108. In cruise at Mach 0.854, 911.9 km per hour, 492.4 kN, and 35,000 feet, its fuel flow at 259 t, 571,000 pound, is 6.8 t, 15,000 pound. per hour within a 5,400 nautical miles, 10,000 kilometers, 6,200 mi, 11 and a half hours early long test flight. 109. Flight test salad raising them to from 308 to 316 t, 679,000 to 6